Hello, in this video I will present an illustrative example of how to solve an MRP table. So in brief, the MRP is to ensure that we have enough parts when we need them. So actually we follow a backward process, beginning by the number of items that we're supposed to deliver at some point of time. So we consider also lead times in the delivery of supplies, and we compare to the order that we have. And following a specific procedure, we determine the order size and timing. And this allows us to control and plan our purchasing. In brief, what we have here is an MRP table. And this is usually being the basis for the calculation of our purchase orders. So in brief, we have a weekly schedule. For example, as you can see here, we have a plan for 6 weeks. For every item in our stock, in our production planning, we have a separate table like that, and we fill that according to the assembly requirements. So the first thing is that we define what we need to deliver every week as a demand. It might be a demand that we have to deliver to some supplier or to some retailers. So this is something that we estimate. The second line is what we expect to receive as orders, meaning that we have ordered some time ago and we expect it to receive as an order from some supplier. The third item is what we have already in our inventory as stock. It may be something that is left from a previous order. If we take out the necessary items to deliver our gross requirements. So on hand means what is left in our inventory and it is available for our assembly line. The net requirement is what we need to order in its time phase, and the order receipt is what we expect to receive at the beginning of the time period if we consider the lead time. And the purchase order, which is the last item, is what we plan to order in its time phase. A simplified example just to demonstrate how all this is combined together is depicted here. Assume that we have to fill the table for one product, which is called product 1. The economic order quantity is equal to 300, which means that the optimum quantity that we should order should be always 300, because we have identified that this fits best in our, let's say, optimizes the cost for holding and for ordering. So we assume that every order should be at least a multiple of 300 units. The lead time for delivery from our suppliers is assumed to be 2 weeks. So here I have filled some values regarding the demand that we expect for every week. For the first week, we're not supposed to deliver something. Second week, 500 items of product 1. In week number 3, 350, and so on. So as you can see here, this is an estimation of what we are expected to deliver from our production line. Now, the schedule receipt shows if we have already placed some order and we expect to deliver to receive some order from our suppliers. As you can see here, we are expecting in week 2 to receive 600 items, 600 units, because we have already placed that order 2 weeks ago. And on hand, we can see that we have 50 units at week 1. So the exercise here asks to fill the rest of the cells of the table. So as you can see here, we have simplified the table. We have removed the previous 2 lines, and we keep only the most important ones just to demonstrate how this procedure is working. As a first step, we need to identify what our production will consume from our inventory. So let's proceed to the first step. In week 2, I need to deliver 500 items. I'm expecting 600 and I already have 50 in my inventory. So in total, I hold 650. If I take out the 500, I am going to be left in my inventory with 150 at the end of the second week. Now, the question here is, if I reach the week 3, I'm supposed to deliver 350 units, but can I deliver them without any order, a new order from my suppliers? We can see that I have 150, so I need another 200 units. So I need to place an order. But as I said, we have a lead time 2 weeks, which means that I have to place my orders at least 2 weeks before. So I have to go back here in my first week and say that I will have to place one order. But as I said before, the economic order quantity is equal to 300, so my order has to be at least 300 units. So I fill the cell here with my order 2 weeks ago, and I'm expecting this to be delivered 2 weeks after. So when I place my order at the first week, I am expecting this order to be delivered at week 3. So as you can see here, all 3 cells here have the same color because my approach is, as I said, to fulfill the needs of the week 3. So I need to consider the lead time and also what I have in my hands at the inventory. So all the 3 items here are actually assisting my planning for week 3. Okay, now let's proceed and see. Assuming that I have this in week 2, how do we proceed after week 3? In week 3, I will receive 300 items. I also have 150, so in total, I have 450. I will consume 350, so what is left in my inventory at the end of the week is 100. Now, again, I repeat the same approach as before. I go and check my week 4. I see that I'm going to need 300 items. I will check whether the items in my inventory on hand can fulfill that. I see that I also need an extra 200, so I need to place an order. And as before, I need to place the order 2 weeks before. But as we said also, I cannot order 200. I need to follow the economic order quantity, which is the minimum of 300. So in week number 2, I place an order of 300 items, and those will be delivered at week 4 in order to fulfill my delivery need. So as you can see here, the yellow, the orange cells follow the same approach. Now, if we continue the same way, we will come in week 4 and we will see that we have in inventory 100, we have a receipt of 300, so in total we're going to have 400 items. We will consume 300, so we're going to be left on hand with 100 items. And again, I check my demand for week 5. I see that it is 1,000. So I say that my on-hand items cannot fulfill that. So I need to order 900. So I go back 2 weeks ago, 2 weeks before the week 5, and I place an order of 900 units. And as you can see, 900 is a multiple of 300, and it fits my economic order quantity because as we said before, my orders have to be a multiple of economic order quantity. So this way, I am in line with all the basic requirements. So I order 900 items in week 3. I expect them in week 5. So I fill those 3 cells like this. Now, if we go a step further, we see that in week 5, I will have in my inventory 100 items. I will receive 900, so in total I'm going to have 1000. I will consume all the items, so what's left in my inventory is no items, 0. So I need to check what is going on what I have to plan for my week 6. I see that I need to deliver 800 items. So I need to order 800 items. But as I said before, I cannot place an order as 800. I need to place a multiple of economic order quantity, so that the smallest order could be 3 times 300, so it could be 900. This way, I can work on week number 6. I can consume that, and what's left in my inventory as soon as my production for week 6 is over is 100 items. So this is a very simplified example of how to fill the MRP table, on how to plan your orders. So the basic idea behind the planning, the MRP planning, is to find a way to fulfill the needs of your delivery, but in a way that also is in line with some other requirements, such as the lead time that you have to follow with your suppliers, or the economic order quantity that it provides you a better inspection of your cost and optimizes your cost. I hope you found this easy to follow. Thank you for watching. Thank you for listening.